This is a walkthrough of Problem 4 on Exam 1 of Module 10 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 4. A fish is a horizontal distance of 80 centimeters away from the edge of a pier. The edge of the pier is 40 centimeters above the surface of the water. The water is calm, clear, has an index of refraction of 1.33. A 5-foot 6-inch person is walking out onto the pier. The fish can see the top of the head of the person when she is 2 meters away from the edge of the pier. How deep is the fish? Let's start by putting the person in, and then the path of the light from the top of the person's head to the fish's eye. There's the person, 5 foot 6 inches tall, 2 meters away from the edge of the pier. The sun is shining, reflecting light off of her, including from the top of her head. Light goes all around, and the fish can see the beam that goes on this path, a straight line to the surface of the water, just missing the edge of the pier, and then refracts down to the fish's eye. Now we have to do some geometry. First of all, we got to convert this 5 foot 6 inch to metric units. 5 feet is 60 inches, so 5/6 is 66 inches. There are 2.54 centimeters in an inch, so that's 1.676 meters. The person's 2 meters away from the edge of the pier and 1.676 meters tall, so we can get the direction of the beam in the air. We can define this angle right here as alpha. Tangent alpha is the height divided by the distance from the edge. 1.676 divided by 2, we can calculate alpha. It's 39.96 degrees, and let's add it to the diagram. There we go, 39.96 degrees right here. Now we can get the angle of incidence for the first refraction. Let's start by drawing the normal. This is 39.96, so's this. So the angle of incidence must be 90 minus that. 90 minus 39.96 is 50.04. We can use Snell's law, keeping track of everything and being careful. N1 is the index of refraction in the air. The angle from the normal in the air is 50.04. The index of refraction of the water is 1.33. And theta 2 is the angle from the normal in the water. And that's 35.19. We can put that on the diagram as well, right here. The angle from the normal in the water. We still have some work to do. We got the angle of travel of the beam in the water. To get the depth of the fish, we need this horizontal distance. The horizontal distance between the normal and the fish. To get this, we're going to get the horizontal distance between the edge of the pier and the normal. Let's call this distance x. If we know x, we can subtract it from 80 centimeters to get the distance we need. We can write tangent of 39.96, that's this angle right here, is the opposite side, 40 centimeters, divided by the adjacent side, which is x. And x is what we want. We can calculate x to be 47.9 centimeters. If we know that's 47.9 and the whole thing's 80, we can calculate this horizontal distance. It is 32.1 centimeters. If this angle is 35.19, this angle must be 35.19 as well. So now we can write tangent of 35.19 is the opposite side, 32.1 centimeters, divided by the depth of the fish. And we can calculate the depth of the fish from this trigonometry, 45.5 centimeters, and that's the answer to problem 4.